Alright, so let's jump right into it. Going to quickly look at the map section for your exam. You were told that you needed to look at your textbook from page 372 to page 373 to look at the maps. I only asked you to know the academic words, the vocabulary words. Okay, so let's quickly run through them and what each one means. First of all, we've got different. So on page 372, it says compare maps with different projections. You need to know what projections and distortions are. Okay. You also need to know what the different types of projections are. Map projections, quite simply, are different representations of Earth, meaning different ways that the Earth is drawn. Map distortions, the parts of the maps that are not accurate. Each way that we draw a map causes different types of distortions. Okay, so map projections. As you can see here, we've got 3 different types of maps. They all are of the Earth, but because the Earth is round, we are not able to draw a flat map and it be accurate in every way. So something is always going to be out of shape. Something is always going to be distorted. Okay? So if we look over here, this map projection, it looks more like a globe. We've got absolutely everything fitting in on this. Okay? But North America is not the same shape in the 2 maps. This map is an accurate representation of the shape of North America, but distances are not accurate over here. We'll go into that in more detail in a moment. Okay. What you do need to be aware of is that, can you see over here we've got lines, okay, crossing over these maps. Now these lines help map makers to know where places are. Your GPS uses these lines. These lines are called lines of latitude. They are the ones that run like this. And lines of longitude, the lines that run like this. Okay, long, going down. Okay, long, long, long. You don't need to study these, but you do need to know what the equator is. The equator is simply the line of latitude that divides the Earth in half from the north and the south. Okay, the equator runs through the middle of the Earth, cuts Africa in half. Okay, we are in the north. People, for instance, living in Australia or South America come from the south. Okay, now we've got, here you can see on the shape of a globe, so latitude measures lines going up and down the globe. Longitude measures lines going around the globe. Okay, the equator is the one that chops the Earth in half. The prime meridian, if I go back here, the prime meridian, because most maps place Africa in the center, prime meridian cuts Africa in half so that we've got the east and the west. Okay. Now, the next thing you need to be aware of is map distortions. Like I said, when we try and draw around a map, when we try and draw the globe is a round shape. But when we try and draw it on a flat surface, something will be distorted. For instance, if you looked at it was impossible just to take a normal drawing of a map of the world and make it into a ball because it wasn't round. That's why I had to give you that funny pattern to cut up to make your project out of. Okay? So when we distort something, we pull it out of shape. And every single map you see that has been drawn on a flat piece of paper is distorted in some way. Okay. Now, the first type of projection I want you to know about is called an equal area projection. You don't need to know these names. You don't need to study the names. You just need to know what they mean. So if I ask you what is an equal area projection, you will be able to tell me. It is a map where the sizes of the areas are correct, but the shapes are distorted. The shapes aren't accurate. Okay? So Africa is this size, North America looks like it's the right size, South America looks like it's the right size. But the shape, North America isn't the shape. If I go back here, see? Shape of North America, shape of North America. The shapes are different. Okay, so that's an equal area projection. Then we have a conformal map. Conformal maps shows directions correctly, so you know where east and west and north and south is. However, the sizes sizes of places are not accurate. Why? Because here they had to stretch the map out to make it flat. So this has been stretched. So here your sizes aren't so accurate. An equidistant projection shows distances accurately from a central point. So you know if you're traveling from here to here, you can measure the distance exactly. Whereas here, for instance, here you don't know exactly how far the distance is, okay? This scale is only accurate at the equator, the middle, okay? But it's not accurate here because this has been stretched. Whereas here, we can now measure all these lines along here are accurate. So the three types of projections you need to know: equal area projection, conformal projection, equidistant projection. Don't worry about studying the names, just know the definition. Okay, you need to know what a projection is, you need to know what a distortion is. Then you were given this worksheet. You need to know the 4 different types of maps. Okay, so these are 4 different ways that we can draw the Earth. The first type is known as the Robinson map, named after some person whose surname was Robinson. It's an example of an equal area projection. Here, the North and the South Pole have been stretched out. Okay, we've got the equator and the prime meridian. Here now, we've got a more accurate representation of the shapes of the continents. At the equidistant projection, we're able to measure accurately. Over here is our equator. Can you see that's the equator there? This is the equator here. The circumference of this particular map is the equator, because we're looking at the Earth from the top. We're over here. Okay, we're seeing this from above. This is the most accurate type of map. But what's the problem with it? Can you see what's wrong with it? Yes. It doesn't show us everything. Here we can see all the continents in these 2. Here we can't see all the continents at once. Okay. So, what do we call this? What do we call this? Prime meridian, equator. Please make sure that you have these answers. This will be in the exam. This is important. You were supposed to do this, okay? I didn't just give you this worksheet as a joke. You were supposed to do this in my absence. Here are the answers. Please make sure that everybody knows about this, okay? Now, let's quickly run through them. Which one looks the most like a globe? So which one looks most like the actual Earth itself? It would be the orthographic. Which map looks as if it were drawn looking down from the North Pole? So which one looks like we're on top of the world looking down? It would be the polar map. The North Pole is shown as a point, meaning the North Pole is a single point. You could put a dot on it. There's the North Pole, there's the North Pole, there's the North Pole. So it's these 3. However, here the North Pole is stretched out. So it's not a single point. Here it is a line. The North Pole is shown as a line, would be the Robinson map. Which map shows only the Western Hemisphere? Do you know what the Western Hemisphere is? The Western Hemisphere is the Earth only to the left-hand side. So it's the prime meridian on the left-hand side. So it's this part of the world. Okay, which map would that be? It would be the orthographic map. Okay, lines of latitude are parallel to each other. Those would be the Robinson, the polar, and orthographic maps. Antarctica is shown much larger than it really is. Here Antarctica is distorted. Here Antarctica is distorted. The equator passes through the center of the map. Equator, equator, equator. That's why I say you need to know what the equator is. Okay, that's the equator, that's the equator, that's the equator. Here the equator does not pass through the center. That's why we do not tick it. Okay? The equator forms the circumference of the map. In maths, you should have learned about the circumference of a circle, the circumference being the outside of the circle. So here, the equator is the outside, because we're looking at the Earth from a different angle. The map is the best one for you for planning an aeroplane trip between Japan and the United States. The reason that the answer is polar is because we want to travel across these lines, and here we can accurately measure distance. Here we can't accurately measure distance, but here we can. Okay. And that's it. I'm going to quickly go over the ministry sheet next.